Hey everybody, this is Larry. This is day 27 of the Leetcode Day Challenge. Yeah, hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about today's farm. Today's farm is Night Dollar. I haven't done this farm before, so it's new to me. Everybody, let's go. I'm still here in Naha in Okinawa in Japan. So yeah, and I just woke up, so I'm working a lot and rubbing my eyes a lot. Excuse me. The chess knight has a unique movement. It may move 2 squares vertically and 1 square horizontally. Okay, we know what a knight is. And the knight can only stand on a numeric cell, a blue cell. Okay. Given an integer n, return how many distinct number of length n we can dial. Okay. First mod. But that should, for a combinatorial number, that really should. But, sometimes you forget. All right. So here, I think the first thing we have to do is they tell you. Is kind of do the map, right? How do we want to write this? For example, you can. There are a couple of ways you can write this, maybe, but like maybe write edges as you go to. I just do it brute force, right? One goes to 6, and you can actually write this out as a whatever, but so 2. Now this is too easy to mess up. So let's just create a thing, right? So dial is equal to right 1 2 3 4 5 6 7 8 9 none 0 none maybe, right? And then now we can create edges just by using a for loop, right? For right. So basically here we're sorry, let me because this is so easy to miss one, so I don't want to do that, right? Right, okay. And then if dial of ij is not none for dx dy in directions, was it next y next y is equal to x plus okay. It's kind of messy. But basically, we're simulating the knight's movement to get the next square, right? Whatever. And none, then we can do edges of tile of xy. Let's make that a tuple, right? And before we move on, let's look at edges to see that we didn't mess up. It is only a medium. I mean, you don't need to do this, right? You okay, that's fine. This is just so that I'm lazy, because you could have created this manually, as I was kind of half doing, but Anyway, now you have these edges, and then now it's just one number at a time. The idea here is saying so let's say we have dp as you go to to 0 times 10, right? 1 for each digit, and dp of x is equal to the number of phone numbers that ends with digit x, right? And yeah, and then so, oh yeah, okay, fine. Maybe off by 1, but so if we have one number, then they all start at 1, so that's the base case. Or like you have one number of one digit, right? So then now, maybe it's off by 1 actually, because we already have one number. Yeah. So then now, how do you do it? Well, then this is just the previous. So yeah, for x, y, and edges, that means that you can go from x to y. Then dp of y as the previous x, right? And of course you have to careful to mod it. And yeah. And then next previous is equal to dp, and that's pretty much it. Have to set it up. Yeah, I mean it works for this random big number. Probably is good, just for kicks. And yeah, that's pretty much it. Did I explain enough? The idea for this one is just dynamic programming, where dp of x is equal to the number of phone numbers and digit x, and of course for each one of these edges, for example, if your next if your one of your edge is 1, 8 as an example, that means that here, well, how many times or how many new phone numbers is there to of the new digit that ends with 8, right? Well, it has to be the previous added one, which is ends with 1. So then now you add an 8 to the one that ends with 1, and then another one is 3, 8, for example. So then 8 also adds from the previous number, and then that ends with number 3, and then it goes up an 8, and so forth. So that's basically the idea behind this problem, is finding these edges and then extending the numbers one digit at a time. You can also do this recursively, of course, top down, with the same logic, right? It's just in that case, then your state would look something like this, something like I'm just gonna get count or something, right? Of digits left, and then the last digit, right? And then now you can do something like, okay, if digits left is equal to 0, return 1, because now you're out of digits. Otherwise, previous digit is equal to, this is pseudocode, by the way, not real code. Some get suppose previous digit, right, from last digit. And you could write this in a number of ways. You could just write like maybe in a for I in range of 10, if I last digit is in edges. Of course, you should, in this, if you write it like this, you have to optimize this so that this is not a linear call, but it should be okay. If this is the case, then total we added to get count of digits left minus 1, and then last digit is I, and then you recursively going, okay, right? So this is how you do it top down. Of course, remember to mod, but I guess this is real code, but it probably isn't super performant. Like I said, you have to optimize this part a little bit. But other than that, and you could also optimize this part if you really feel like it, so you don't have to do a for loop. But other than that, and memorization, obviously, this is probably very close to the real code. So definitely you can play around with that if you are top down. I definitely skipped a little bit ahead to the bottoms up and space optimization because that's just how I do combinatorics. But yeah. What is complexity? Well, if we do it this way, then clearly the space is going to be O of 10 or O of 1 or O of D for the number of digits if you want to put, or not digits, but like the number of digits on a phone. And O of N time, right? Because, well, you have an O of N loop. And here is just O of D square, if you want to call it that. Excuse me. And also this is not O of D squared, this is O of D, I think, because O of D, you just look at 8 of them, so O of D times direction or something, I don't know, something similar, but sorry friends, but yeah, that's what I have for today, that's what I have for this one. Let me know what you think. Like I said, dynamic programming, a couple of ways to do it. Combinatorial prompted, generally dynamic programming special at this level. So, yeah. Or, I mean, it could be similar with a formula, but the hardest it gets is DP. Yeah, that's what I have for this one. Let me know what you think. Stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye-bye.